Okay, so next problem is gonna try to solve. There's different ways to add parentheses. So there is the same issue that happened like yesterday. So I recorded a video, I was solving it, but the problem is that I didn't like the sound was bad. So I'm re-recording that, and I'm gonna be trying to explain how to solve this problem. So this problem is two for one different ways to add parentheses. To be honest, I was thinking about this problem a couple days and still was not able to come up with a more or less good, efficient approach. And then I checked the solutions and it was pretty easy idea to grasp. So I'll try to program the approach. So the idea behind the approach, so we have like expression and we need I need to put the brackets in all the possible combinations and record the output after applying those brackets to this expression. So that's gonna be what's gonna be my approach to this problem. I will do the following. So let's say we have 2 minus 1 and then minus 1. So I'll go through this expression. Every time I see a number, I gonna kind of skip it. And then every time I see the operand, like plus, minus, or multiply, I gonna split the expression into two parts, like left part before the operand and right part after the operand, and then I'll evaluate this like this left and right separately, returning their array of result, res1, res2, and here also gonna be like only one res1, whatever, like res_n, and then I return it from the recursion, this one array and this one array, and then I'm gonna unify those arrays by taking one number from the first array and taking number from the second array and applying this minus operation here. That's was joining the operation that was joining this left and right parts. So that's approach I wanna follow, and in this case, let's check what's gonna happen. So say we have like this 2 minus 1. So I'm gonna split this. It's gonna be 2 separate minus 1 minus 1 separate, and then the second operand 2 minus 1 minus 1, and then gonna be minus and then 1, and then this one gonna evaluate just to 2, and this one just gonna evaluate to 1, to 0, and then combining this two numbers, I'm gonna be 2 minus 1, 2 minus 0, so because this is gonna be the result gonna be what, 2 minus 0, 2, and here gonna be, I evaluate this expression gonna be like separately 2 and then minus 1, and then 2 minus 1 gonna be 1, and that's gonna be 1 minus 1 gonna be, so it's gonna be 1, gonna be 0, and then they're gonna be go up with so this one gonna evaluate to 1, not gonna be evaluated to 1, and 1 minus 1 gonna be 0. So here goes like 2, array 2, here goes array 0, and we unify it, it's gonna be the result 2 and 0. So in case I wanna do something else, let's say I want other expression, Let's take the expression from the example 2. We're gonna be 2 by 3 minus 4 by 5. So again, there possibly like 1, 2, 3 branches. It's gonna be 2 multiplied by 3 minus 4x5, and that's gonna be 2 by 3 minus 4x5, and that's gonna be 2 by 3 minus 4x5. So this one gonna be 2, and this one gonna be again 3 minus 4x5, and that's gonna be second one 3 minus 4x5, and this one gonna evaluate to 20. 20 minus 3 minus 20 gonna be minus 17. It's gonna be bubble up, and this 3 minus 4 gonna be 3, and minus 4 gonna be gonna bubble up minus 1, and minus 1 by 5 gonna be bubble up minus 5, and this one gonna bubble up 17. Okay, so it's gonna be minus 17 and then minus 5. So it's gonna be unified, and minus 17 by 2 is gonna be minus 34, and then minus 10. So this way gonna bubble up, and here I'm gonna bubble up, so gonna be 2 by 3, so 6 minus 5 minus 20. It's gonna be what? 6 minus 20 minus 14. Gonna bubble up minus 14, and here, so I have 2 by 3 minus 4, and that's gonna be 6. 6 minus 4 gonna be 2. 2, and then the second one gonna be 2 by 3 minus 4. 3 minus 4 gonna be minus 1, so gonna be minus 2. So 2 by 5 gonna be 10, and then minus 10. This is gonna bubble up to here. So the result here is just union of this. So every time we have like this one, we unify the result. Every time we have like operation, we apply operation to every kind of every number from this tree, from a subtree. So the result here gonna be this minus 34, minus 10, then minus 14, then minus 10, and then 10. Or like if I change the minus 14, then minus 10 here. And this is exactly what we have, what they have for the output. So this is like entirely based on the recursion solution, based on the recursion. And then there is another approach how to use memoization, and like, another approach is like how I can optimize even memoization, even make it better. So let me try to code the solution. So I'm gonna go for if, let's say if I'll change the variable name to make it shorter. If x length is equal 0, then I'm gonna return. So I'm gonna have this list integer res equals new array list, and then I'm gonna return res, and then if x length less than 2, less or equal to, I'm gonna res.add integer value of x, and then return result, and then I'm gonna go for int I equals 0 while the next for length I plus plus. I'm gonna have list if the char ch equal x char at I, and then if char not equal plus and char not equal minus and char not equal multiply, then I gonna return I gonna just continue, else I gonna do the split list integer left equals I'm gonna call the same function, but x substring 0, and then call it k chart k, and then k, because I don't want to include k's character, so I'm not including k, from 0 to k, not including k, and then list integer right equal if the same, but here it's going to be k plus 1, and then x dot size or length, and then for int I equal 0, I less than l length, and then let's say size I plus plus. Now for in j equals 0, j less than added size j plus plus, and then if character is equal plus, then I wanna press plus, then I wanna here also multiply. I wanna res add char get I plus right get j, and then if character is equal minus, I wanna go res add left get I minus right get j, the same if character is equal multiply. I wanna do res dot add right left get I multiplied by right get j. Then in the end, so we're gonna be adding this one, and then in the end I wanna just return res, and that should be it. Yep. So the next idea is to use memoization, because instead of like running and calling that function every time, will be like intersecting expression, etc., etc. So I can use memoization to record array of results for evaluating substring of expression from start to end. And start to end gonna be this indexes in this DP array. And the value for the 2D DP array gonna be list of integer, and gonna be the results of evaluation for the substring from start index to end index of a string expression. So for this purpose, I need to go private. Let's say go private void dp. I wanna have start and then string exp, and then I want to have this list dp, and then if dp start and not equal null, return dp start and then end. And here I want to go if start, I want to just, I don't want to return, I just will, okay, if start less if let's say start less than 0, or start is greater or equal x length, or end is less than or equal 0, or end is greater x length, I want to just return if start, if end minus start less or equal 1, I want to go dp start and okay, list integer I'll equal new array list, and then I'll add exp substring start and plus 1, and then I wanna have this integer value of, and then save it there, and then save it, and then return, and then for int I equal 0, I less than no, for int I equal start, I less than start, I less than equal and I plus plus. Or let's say I want to use the same key equal start, k less than and k plus plus. I want to do the following: if k is equal if okay, char character this one, and then if it's not equal this one, I wanna just continue, and then if it's equal I wanna get if dp left or like start k minus 1 call now. I wanna do dp start k minus 1 exp and then dp, and then list integer left equals dp start k minus 1, and then if dp k plus 1 and is equal now, I wanna do dp k plus 1 and expression, then dp, and then list integer right is equal dp k plus 1, and then I wanna unify that as I did it here. And then I have this list integer left equals new list, then list add, and then I want to do this in the end, dp start and equals list, then that's it, and then I want to call this dp, so the int n is gonna be expression.length, then list integer dp equals new array list and then n, and then I want to call this 0 n minus 1 expression and dp, and then I want to return dp 0 n minus 1. So I partially wrote this recursive approach to add optimization to recursive approach, so that if we already pre-calculated the all possible values for evaluating substring from start to k minus 1, I just gonna get it from this dp array like matrix, and the same for the this one for the left and this one for the right. And if we have it cached, just instead of it diving into the recursion, I just return it from the dp array, and then I apply the same kind of procedure when I unify two parts. Not unify, but do what? Combine left and right, and apply the operation that's between these two parts. And then I assign it, cache it, and then for the main function, I just create this dp array, and then call the function for the start 0 and n minus 1, and then return the value that's stored inside the between, like, all the possible values of evaluation of the expression between 0 and n minus 1. Okay. Compile private int. What's the problem? Okay, list. I wanna have integer. Integer left. Okay, so it's gonna be left. It's gonna be a right. Yeah, so it's like better, but I can even do the better than this one. So the problem with this approach right now is that it's still using this recursion, and how to, instead of like avoid, like instead of doing of this recursion, how to avoid it, like and how to do like tabulation. So I would probably go with the following, like if I would have more time. Let me make it smaller. So what I would do, let me check what the time is it now. That was already 26 minutes. So what I would do is, like, let's say we have this expression, 2 by 3 minus 4 by 5. So I would do, and I would go through this expression, and I'll save all the numbers into array list, and then I'll say also I'll save all the operations, all the operations into other array list. So let's say one array gonna be 2, 3, 4, 5, and the ops gonna be multiply minus multiply. And then I will create this matrix, and the matrix it's gonna be the DP array. And then first I gonna, like, and the number of like cells gonna be exactly the number of operands here. So like 4. And then the diagonal of this matrix, so it's gonna be here gonna be start index 0, 1, 2, 3, and then 0, 1, 2, 3. And then on the diagonal is going to be the result of the evaluation of the expression. It's kind of, now it's splitted, like numbers and operations, but like the result of the evaluating of the operation, whatever, like it stays between number 2 and 2. So like this one. So it's going to be 2, 3, 4, 5. Just fill up the here. It's gonna contain the array. So it's gonna be array of single element of 4, and this one is gonna be array of single element of 5. And then here gonna be like 2. Here gonna be 3. And then I need to fill up all this elements above the diagonal. The diagonal is like pretty easy, just go one by one and fill it up. And how can I unify, let's say, how I can fill this cell? So I know that this cell should be like all results that are evaluated between these two numbers. So it's going to be between those two numbers are just the operator like multiply, so it's going to be just 6. And the same for this, between these two numbers the operator is going to be minus, so 3 minus 4 going to be minus 1. And here gonna be the same, 4 and 5 are gonna be multiply, 4 and 5 gonna be 20. And then here, next iteration gonna be, so to get their kind of result of evaluating of expression that stays between numbers 2 and 4. So it's like 0 and 2, 0 and 2 is going to be 0, 1, 2, 3. So 0 and 2 is going to be 2 and 4. I need to use like to combine to, let's say I have a k, and k like stays here, and I check out the operand here, and the operand here is like multiply. So like it's going to be 2 multiplied by this expression, and this expression I already know it. It's going to be dp 1, 2, and dp 1, 2 is going to be 1, and 2 is going to be minus 1. 2 multiplied by minus 1 going to be minus 1, or minus 2, and then k moves to this location, and then the same. I need to evaluate 0, 1, dp 0, 1 gonna be what, 6, and then here gonna be minus, and this gonna be 4. 6 minus 4 gonna be 2. And then I need to evaluate this one. So the same, I need to evaluate expression that stays between 3 and 5, between indexes 1 and 3. So 1 and 3 is this one, 3 and 5. And then again I have k that's moving between, like, the first position for k is here. So it's gonna be 3, and then 3 is so the 3 minus, and then 4 and 5 is dp 2, 3. 2, 3 gonna be 20. 3 minus 20 gonna be 17. Minus 17. Gonna be minus 17, comma. And the second result gonna be by moving k here between 4 and 5. And then dp 1 and 2 gonna be 1, 2 is gonna be minus 1, so it's gonna be minus 1, and then here multiply by 5. So 3 and 3, dp 3 and 3 is gonna be 5, so it's gonna be minus 5. And now I need to derive the final cell, and again I need to go k, like, so now I am evaluating the whole entire expressions, this kind of expression, and then k goes like here, and that's gonna be dp 0, 0, then multiply by dp 1, 3, and then gonna be the second value gonna be, so dp 0, 0 gonna be 2 multiplied by dp 1, 3, 1, 3 gonna be like 17. So it's gonna be 2 multiplied by 17 and 2 minus 17, and 2 multiplied by 5, so it's gonna be minus 34 and minus 10. And then I move k here, and that's gonna be dp 0, 1 minus dp 2, 3. 0, 1 dp 0, 1 gonna be 6 minus dp 2, 3. 6 minus 20 gonna be minus 14, so gonna add minus 14. And then k gonna move to this location, and then for this k it's gonna be for this k I need to go dp 0, 2 multiply by dp 3 and 3. dp 3 and 3 gonna be 5. dp 0, 2 gonna be minus 2 and 2, and this multiplied by 5 and gonna be minus 10 and 10. So this is gonna be the result: minus 34, minus 10, minus 14, minus 10, and 10. And yeah, this is gonna be like bottom up, I guess it's called bottom up approach for DP. Yeah, so that's, I don't wanna like program that right now. I hope you understand what I mean. So I claim it as a pass, so I managed to explain like 3 approaches.